Okey, boleh nampak ya? Yang dalam my teams boleh nampak ya? Boleh, okay. Alright, so next, okay, so now look at this question 11. So this one is a June 2019 question. So a decaying electric and magnetic field is 200 exponent negative 5t. So it's connected in series with 20 ohms resistor and 0.01 farad capacitor. Okay, so based on this statement, we identified that we have this series electric circuit which connected between resistor and capacitor, which is RC electric circuit. RC series. Okay, so bila RC series, so means that the equation is about VR plus VC equal to the total of voltage. Okay, so sebelum ni kita discuss RL circuit. So now we have another series circuit which is VR and VC ataupun resistor and capacitor. So the equation it will be, dia berbeza sikit lah dengan RL circuit . So just recap untuk electric circuit. Recap ni. Okay, so electric circuit kita ada, sebelum ni kita sebut RL circuit . So RL tulisan ni dia mengikut keadaan. Kadang cantik, kadang tak cantik. Ya, I adjust jap. Sekejap ya. Okay, so RC circuit, RL circuit. Sebelum ni kita belajar RL circuit. So RL circuit is a VR plus VL, then here we have the total of voltage. Okay, so actually in electric circuit we have three basic variable. Okay, iaitu VR. VR is about IR. R is resistor. And we have VL. VL is a voltage across inductor. So inductor is L di dt. Okay, so L is the inductor multiplied with the rate changes of current at any time t, and we have another one which is voltage across capacitor, which is 1 over C. So C is a capacitor multiply with Q. Okay, so where Q is a charge. So kat sini ada lagi dua perkara yang perlu tahu, iaitu untuk I is a current rate changes of charge at any time t, which is I is a dq dt. Alright. So when we talk about RL circuit yang ini, so the equation here is, equation dia adalah VR, which is IR plus L di dt, and then plus voltage, total of voltage ataupun total of energy. Okay, and lagi satu kita ada the one is VR and VC. VR, VC kita panggil sebagai RC electric circuit. Okay, so the equation here is VR plus VC equivalent with total of voltage. Okay, so the equation it will be IR plus 1 over C Q equal to V. Okay, so therefore the equation for RC electric circuit it will be R dq dt plus 1 over CQ equal to V. Okay, so untuk case yang ini, for this one, we concern on the charge at any time t, which is Q of t. Okay, so kalau untuk yang atas ni, untuk RL circuit, so we concern on the current at any time t. Okay, jelas? Faham So kita ada dua equation untuk electric circuit, satu RC, satu RL. Okay, so this one is for which involve R resistor and capacitor. Okay, jelas? Okay, so untuk yang dalam Teams ada soalan tak? Ada. Okay, so based on this question 11. So here we have about RC circuit. Okay, because this circuit connected between resistor and capacitor. Okay, so based on the information given, we have this one. Electric and magnetic field, the total energy is 200 exponent negative 5t. So this one is our voltage, total of voltage. And then 20 ohm resistor. So R is 20. Okay, resistor is 20 ohm. And the other one is capacitor. So our capacitor here is 0.01 farad. So the unit for capacitor here is farad. Okay, so next, assuming no initial charge. So this one, we can say that when t equal to 0, so the charge is 0. The charge is 0. So here we can say that, or we assume that Q at t equal to 0 is 0. So this one is our initial value. Alright, so next the question asks you to find the charge of a circuit at any time t. So here we need to find Q at any time t. Okay, charge dalam symbol dia adalah Q lah. So current is I. Okay, jelas. So now we need to find the Q of t. Alright. Okay, ada soalan setakat ni? Boleh teruskan? Boleh. Okay, so now we need to develop the equation. So based on the statement in question 11, to identify semua, so we have R is 10 ohm and C is 0.01 farad, and our energy is about 200 exponent negative 5t. 200 exponent negative 5t. Okay. So based on this, we insert all the information in this equation. Then here we have, you masukkan je resistor tadi 20 ohm. 20 ohm. Okay, so masukkan equation ini. Then here we have a 20 dq dt plus 1 over 0.01 Q, and it is equivalent with the total of energy, which is 200 exponent negative 5t. Okay, so based on this equation, we identified that this one is about linear differential equation. So ini adalah linear differential equation. Differential equation. Okay, so next, the coefficient for dq dt, we need to make it as a 1. So bila diadakan ada 1, so we need to multiply all the terms by 20. So divide all the terms by 20. Kita jadikan coefficient bagi dq dt as a 1. Okay, so next step, we divide all the terms by 20. So here we have dq dt plus, so 1 over 20 times 20 times 0.01, we have 5. 5q. 5q. Equivalent with 200 exponent negative 5t. Okay, so here we need to find kita question apa?
Yang tak payah bahagi.
Bagi.
200 kepala.
Bagi. Semua bahagi dengan 20. 10 exponent negative 5. Okay, so ni you kena cari integrating factor. So first we need to find integrating factor. Integrating factor. Okay, so which is u of x, u of t, kita guna t sebab variable dia adalah t. U of t equal to exponent integral p of t dt. And next one, we find general solution.
I over ut. 1 over ut.
Okay. So the general solution in terms of q of t, charge at any time t, which is 1 over q of t, which is integrating factor, multiply with q of t. And tadi kita masukkan e of t lah kat sini. E of t multiply with u of t. Respect to t. Okay. Right, so next. Kita cari lah kat sini. First integrating factor. Okay, cari integrating factor. Faham tak? Kalau tak faham, saya tanya. Jangan senyap je. Okay, so P of T kita apa kat situ? P5 and our E of T here is 10 exponent negative 5T. So ini penting yang kali hijau ni sebab kali hijau ni yang kita untuk dapatkan integrating factor and the general solution. So masukkan P of T. We have 5 integrate respect to T. So here we have exponent of 5T. So this one is our integrating factor. Alright. So next kita cari general solution for charge at any time T. Q of T. So our Q of T here is 1 over integrating factor exponent 5T. Multiply with the integral of E of T. E of T is a 10 exponent negative 5T multiply with exponent of 5T. Okay, so inside here we can simplify. Dapat apa tu? Exponent 0 is? Exponent 0. 1. So 10 times 1 is 10. Okay. Alright. Mudah je. Just integrate. Then here we have 1 over negative 5T multiply with 10T plus C. So therefore this is our Q of T. So sekarang C is a constant. So now we need to find C. So how to find C? We use initial value. So the initial value here is when T equal to 0, so charge is 0. Okay, Q at 0 equal to 0. So you masukkanlah T kosong untuk dapatkan nilai. Okay, so now we have Q at 0, 1 over exponent 5 times 0 multiply with tadi integral kita dah integrate tadi kan? Kecil pula.
Si memang kosong.
Nampak ya? Nampak, okey. So masukkan je ni kosong ya. 5 times 0 times 10
Times 0.
times 0 plus C equal to 0. Okay? So 1 over exponent 0 is 1. So 1 times 10 times 0, we have 0 here. And this one, 1 times C, we have 1 times C, C equal to 0. Okay? So therefore, charge at any time t is 1 over exponent 5t multiply with 10t plus 0. Okay, you simplify yang ini. Then here we have charge at any time t is 10t over exponent 5t. And it is also equivalent with 10t exponent negative 5t. So you bawa exponent 5 ke atas dan kita akan dapat the power here is negative. Okay, nah, so inilah jawapan dia. So based on this equation, you can estimate for the charge untuk certain time yang you nak. Katakan the charge after 10 minutes, so you just enter t equal to 10 and you will have the charge lah. Alright? Okay, faham? Ada soalan? Yang dalam item ada soalan? Tak ada. Okay, any question? Okay, so kalau tak ada, kita tengok soalan lain. Day 5. Azri, ada soalan Azri? Tak ada. Okay. Alright, so kalau tak ada, kita tengok soalan yang lain. Okay, question 10. So question 10 ni boleh buat Question 10. Cuba buat. At time t equals to 1, a bacterial culture of Streptococcus A cells is recorded at 450. Okay, so ni nama bakteria tu, Streptococcus A. After 3 hours, so after 3 hours, it increases to 1,227 cells. So find the number of original cells at t equal to 0. Okay, so based on this statement, which model that we can apply? Model apa? Population growth.
Yeah. Population growth. Jadi biskit dah ni. Bukan lampu balik.
Okay, next. Okay, so this one. Okay, lain pula. This one So this one, kita guna apa? Okay, so dia ada keywords dia. So kalau nampak dekat sini, bila ada melibatkan increases, so maksudnya the bacteria is grows. Okay, so based on this statement, we identified that at t equal to 0, so the sample of cell is at 450. Okay, so after 3 hours, it is increases to 1,227 cells. Okay, so we record the bacteria at T equals to 1. So we have 450. And after 3 hours, which is at T equal to 3. So here we have 1,227. So the increase. Okay, so based on this, we can say that the model here is based on exponential growth, which is dP dt
per P.
Kp, where K is a constant, proportional constant. Okay, so K is always positive. Okay, so kalau dia melibatkan decrease, dia punya sample ataupun dia punya population menurun, so that one we use negative Kp. Okay, so you kena tengok ayat dia. Alright, decay. Dia punya keyword dia decay ataupun decrease. Kalau ni growth, increase, so we use this model. Alright. Okay, boleh buat. Okay, yang dalam my things cuba buat dulu. Nanti kita discuss jawapan.
Dia susah cari P0
So you need to derive. You need to find you need to find P of T. So how to find P of T? Kita apply equation yang mana?
PT AEKT. AEKT. Yes.
Kita derive, apply separable equation.
Ni, yang ni formula dia. General formula untuk growth kan. Population growth ni. So kau apply je lah. Masukkan nilai T tu dekat.
Dah ada minta-minta demam tu. Sekarang ni demam viral. Virus.
Oh, virus.
Teruk gila kau.
Sorry, tak dengar.
Demam dia agak lama jugalah nak pergi.
Saya dapat dia.
Kesiannya. Kesiannya orang demam.
Ya.
Anak jadi PT kan. Dah, tu dapat equation ni. Coba kan tutup mic.
Nak batu tutup mic sayang.
Sama. Batu tak equation.
Tengoklah kau kena buat simultaneous equation.
Ya, teruskan. Saya cuma melihat ni.
Saya pun tak tahu macam mana nak buat awak. Kau kena cari dia punya original dulu untuk yang itu zero.
Tak, itu dah akhir dia.
Oh, itu akhir.
Kita mula samakan lah. Kan dah ada formula A, E, K, G tu kan.
Oh, macam samakan
So,
dua belah.
Kita bagi time 1. So, G tu dah satu. Equal tu dengan 4 bit tu.
Lepas tu. Aku dah buat sampai situ dah.
So, bila sabarlah. A, E, K dengan 4 bit dulu.
So we separate for P and T. P and T. Separable equation ni.
dP over P. KDT. Queen.
Take both side. Then we have H of P, KT plus C. Okay, so we take as for the left-hand side because we want to find T of P. Okay, kita ambil saja.
Laju.
Ya lah. Oh ya ke?
Kesiannya.
Okay, so this is
Jadi pintu ke?
So we say that P and T equal to A,
Oh,
exponent of B. So, in exam, ni semua yang kena tunjuk kan?
Oh.
This one is 3 marks. Macam mana you dapat 3 marks? You identify the model and then apply separable equation, separate the variable and integrate this
Macam
side.
mana kau dapat benda ni pun kena tunjuk.
So, this is this one.
Ni step first. Ni aku dah skip step.
Jawapan dia satu.
DDT sama dengan
So this one, 1 point. So we have about 1, 2, 3. Satu markah. Sekali lah dengan proses ni.
3 markah. Yang ni cukup kot. Sampai sini je cukup.
Ada lagi 4 markah tu kan 7 markah tu.
Boleh atur.
balik je. Balik ni tapi ada makan.
Okay.
Aku masukkan nilai.
Question berapa tadi? Question. Okay, teruskan. Cari apa? Variable constant A and K. So how to find A and K? Solve the simultaneous equation. What?
Oh, kau bagi juga lah.
Masukkan tu kita ada 2 at t equals to 1 450, t equals to 3 1227.
Kalkulator jadi mana?
Boleh. Lepas tu 2 bahagi 1. Kau bahagi 2.
Tidak, 2/1.
Ni kan equation kedua. Yang equation pertama. Kau 2 bahagi 1. Tak, masa aku yang ni equation kedua.
Wah, dia.
Kau 9. Kau 150 kan?
Dapat tu, jangan.
Oh, faham.
Tak ampun. Tak boleh nak. Dapat sesuatu ni.
Ni kau biasa out kau nak cari apa?
Kan A
Oh, nak cari K dulu nak.
cari E dulu.
K.
Doktor ada link tak yang untuk kelas online ni?
Online?
Ke sebab
Yang mana?
kan doktor buat online.
Nak cak?
Nanti saya bagi. Saya tak upload lagi.
Oh, nak ingat nak masuk yang sekarang ni tengah masuk online.
Boleh nanti. Yang ni pun saya akan upload. Lagi? Okay, so we need to find the original style. Berapa? Okay. So based on this information, we identified that this is about proportion growth. So we use this model, which is dP dt equivalent with kp. Okay. So this one is a separable equation. We will apply separable equation. So how to apply separable equation? We have two steps. The first step, we need to separate for P and T. Okay, so we separate for P and T.
Kau masukkan.
And then integrate both sides. Then we have natural log of P equivalent with KT plus C. Okay, so in order to get P, we need to take exponent left hand side and right hand side. Okay, so now we have P, which is equivalent with exponent KT. We simplify for this exponent, multiply with exponent of C. So since C is a constant, so exponent of C is also constant. Okay. Alright, so in order to find find A and K. So we use this info.
yang dah bagi.
Yes. So for this simultaneous equation, which is P at T equal to 1, we have A exponent K times 1 equal to 450. This one is the first equation. And the second equation, it is about T equal to 3. So we have A exponent 3K. It is equivalent with 1227. So this one is about second equation. Okay, so we solve for this simultaneous equation by dividing second equation and the first equation. So divide by 1. Second equation divided by first equation. Then here we have A exponent 3K 1227 over exponent A exponent K 450. So selesaikan this one. In the left hand side we have exponent 2K equivalent with 1000. Ni 1000 bukan 1 point.
Kalau macam 409 100
2.727. So find K. So how to find K?
Tak lon.
We take ln left hand side or right hand side. We
Yeah.
simplify for this exponent.
Let's go into the case.
Okay, so in the left hand side we have 2K 2.7267. So therefore our K is divided by 2. So our K is 2.727 over 2. 0.501.
Kena ambil 4
Biasa kita ambil 4 decimal places. Unless kalau soalan minta 3 decimal, then you need to give 3 decimal places. Okay, so hence we can say that P of T it is equivalent with A exponent
0.5.
T.
Dari A.
Okay, so next we find A. Find A. So in order to find A, you can take either T equal to 1 and 2. You can ada 2 kan? So you boleh ambil salah satu. Okay, so for this case, I take the first one, which is at T equals to 1. We have A exponent 0.015B. P is 1, equivalent with 450. Okay, so A is 450 divided by exponent
0.50.
Okay, berapa A?
272.
272.
272.94.
Sampai
272.5
2.5 kalau kita ambil pasal begitu.
297. And A is approximate to, so this one you can take either 272 or 273. Sebab dia 5 kat sini kan?
Oh, mana-mana boleh lah.
Dua-dua jawapan tu betul. Unless kalau 6 kat sini, you kena ambil 273.
Kena ambil 3 kan?
Check.
Ya.
Okay. Okay. So therefore, the population of bacteria ataupun the cells At any time t, here is you masukkan
273 exponent
273 273 exponent 0.5015 t. Okay, so the original cells,
P0.
so bila dia kata original cell means that p equal to 0. Masukkan. Times 0. So here we have 273. Okay, so the original cells is 273. Okay, boleh? Ada soalan?
Ya dia.
Okay, ada. Okay, ada. Bagus. Girls, okay? Ladies? Men? Di dalam web? Any question?
Benda hidup tak ada spark. Separuh yang belah itu. Personal tu personal sangat.
Right, so yang ni nanti saya share dengan you all. Tengok apa lagi you nak?
Jadi apa lagi nak? Nanti sebab doktor dia 0.505. Kalau kau ambil 0.5 je memang dapat.
Point
9.
Okay. Saya ambil berapa decimal places tu dia akan effect dia punya jawapan akhir lah. Lepas tu to be safe, kita ambil 4 decimal places. Okay. Kecuali kalau dia minta. Tu you kena bagilah. Kalau 3 decimal places, walaupun places tu 000, so you need to give the answer in terms of 0.000. Okay. Alright, so kita tengok soalan. Ada soalan tak? Tak ada? Faham Okay, very good. Kelas ni bagus.
Habis.
Jom. Kau tak boleh puji Okay, so question 10 ni. Yang ni melibatkan 3 components. LRC, so this one is the second order. Yang ini second order differential equation. So ini kita discuss nanti. Kita tak masuk lagi bab ni. Sebab dia ada 3 komponen.
Ada
inductor, resistor and capacitor. Kalau 2 komponen kita guna first order. Okay?
Order.
Yang ni dah discuss ke belum?
Kenapa?
Question 9?
Belum.
Sorry ke?
Belum
Yang 10. 10 tadi tu.
Alamak, battery nak habis.
Nak juga. Tapi tak masuk lagi.
Tak masuk lagi second order.
Apa nak buat dah?
So dia nak buat.
So dia buat ke depan doktor.
Tak apa, kena soalan dia.
Kenapa?
Nak ke? Nak gambar kat dia? Oh, belum.
Belum. Tak discuss lagi yang tu. Okay, so buat question 8. Kalau bateri saya habis ni, kelas habis lah ya.
Sikit.
Sebab habis. Okay, look at this question 8. So this one is about animal fossil. So an animal fossil has 300 milligram of radioactive isotopes when it is found. So scientists analyzed that 2.5% of the isotope decay after 2 years. Mereput selama 2 tahun. Selepas 2 tahun. Okay, so if the amount of isotope decay proportional to the amount present, so find the amount of isotope at time t. So this one you need to find the amount of isotope at any time t, which is you need to find P of t. So P is amount of isotope. You kena cari.
So P0 dia 300 tu.
Initial
300 tu P0 lah.
Yes. Dijumpai. Okay, so this one you can say that P at T equal to 0 is 300 milligram of radioactive. And then analyze.
P2.
After 2 years, it decay 2.5%. So maksudnya berapa tu? 100 minus 2.5.
75. Bukan. 7.5. Apa buat ni?
Ini sebab yang tinggal tu 97.5 lah kan? Times darabkan dengan 300. Betul kan ni?
300 mili ke? Mili tu tak kira.
Ha?
Mili tu kena ambil ke tayang?
Miligram tu dia punya unit. Kalau you nak letak.
Dapat 292.5.
Tahu ada.
292.5.
Kalau
292.5.
Darabkan dengan 300. 295.5.
292. 292 ke
292. So after 2 years,
kita balik ke tidak mampu.
Nak makan tinggal dia.
ya.
Aku nak tanya.
Okay. Tak.
Apa yang jauh mana?
Jauh sangat tu. Dia pun dah penat. Aduh.
Nana, sign.
Yep, saya ada tak. Okay. Kita tak. Saya boleh pasal.
Lari.
Sebab dah sikit dah habis. Sebab saya seorang je. Partner saya tadi COVID. Oh, ya. So, macam mana?
Sadaqallahul azim lah.
Jadi dah doa
Dia kan sepatutnya dia suruh cantik. Dia tak cantik. Tak boleh.
Kalau yang bawah tu tukar tak? Dia ada satu lubang. Oh, itu VGA.
So times 300. So after 2 years, the weight ataupun radioactive isotope 292.5 milligram. Okay, so it has been decayed 2.5%. Yes. Alright, so next you can cari P of T. So based on this one, dia mereput. Jadi kita gunakan apa? The model here is negative KP. Okay, we use this model because it is about a radioactive decay. Okay.
Tinggikan je lah.
Sama juga. Dia punya procedure, you need to apply separable equation.
Tambah negatif je mama.
December 2019.
Eh,
300. What eh?
buang lah. Kau dapat nilai A.
But into
Tu dapat nilai A.
Ah, tu dapat nilai A. Ha?
Mana ni?
Boleh, kena bahagilah.
Oh, memang boleh. Kata ilmu.
So, tak elok. Awal lagi sana. Buat macam tadi, buat macam tadi. Kena substitute T kosongan T2 dulu. Bahagikan baru dapat nilai A.
Macam nilai K mama.
Mama.
Nilai A tu kau boleh dapat terus lah.
okay. So we need to find this one. Alright. So kita ambil ni. At T equal to 0. So we have P0. Sebelum buat ni, kita kena identify the model.
Untuk 3 markah kita tu.
Yes. Betul. Kita negatif K dt. KP. Cukup KP, bukan PKP ya. So apply separable equation. So we separate for P and T. So we have P over P equal to negative
Sebab kalau kau buat ni.
Kosong.
Ya.
Benar lagi dapat.
Okay, so we take exponent left hand side, right hand side.
500. So 300 T negatif 2 T sama dengan 29. Ini dua T sama dengan 900.
Okay, so this one is the P of T and A equal to exponent A, exponent negative P.
Bahagi negatif 2. 0.01. Substitute negative 2K equivalent with
Negatif lagi.
292.5.
Ada
Okay, so find K. So ni kita cari K lah. Okay, sebab A dah dapat. So find K. Okay, so how to find K?
Ya.
Cari K. Okay, so exponent negative 2K, it is equivalent with 292.5 over 300.
Half-life dia boleh negatif.
Kau dah
Ya.
half-life mesti separuh ada 300. Ambil berapa?
Tak nak cari pun. Yang kerana saya ada setengah.
Dia jadi negatif sebab fikir.
Negatif.
Sebab jadi negatifnya.
Oh, dia negatif ni. Aduh, aku semua. Kasi negatif.
Ah,
Patutlah. Jawapan dia tak ada negatif.
okay. So bila cari ni dapat K dalam positif kan? This K is positive.
Boleh jadi editor tu dia jadi A over D ni plus P kan anytime tu. So kita sampai contoh sebagai contoh. Sebab tadi kan
Bila dia ada negatif. Ah, okay. Faham. Okay, so untuk model ini dia ada key dia kalau dia melibatkan decay. So this one ada decay kan? So decay means that the K is negative ataupun decrease. Maksudnya dia punya bilangan populationnya menurun ataupun dia punya weight dia menurun. Itu decrease lah. So that one we use negative KP. Kalau increase, growth, so the model is positive K. Macam tu. Right? Yang tadi, okay. So cari K. Okay, so this one equivalent with 0.975. Okay, so in order to find this K, we need to take natural log left hand side, right hand side. So let's simplify for this negative 2K. Okay, so kita letakkan, kita ambil natural log. Dah dapat dah K.
Dah.
So here we have negative 2K equivalent with natural log 0.975. So our K here is 0.975 over negative 2. So K is
0.0127.
divided by negative
127.
6.
Lagi.
Mana tu dia? 127. Okay. Therefore, the radioactive isotope at any time T is, dimasukkanlah A dengan K. 300 exponents negative
0.0127.
3.
So dia minta apply.
Okay. So this one is the first question. Di my teams, dapat tak jawapan ni?
Dapat.
Teams.
Sabar. Kau okey boleh padang kau.
Firdaus, dapat tak jawapan?
Dapat, Doktor.
Dapat. Okay, very good. Alright. So this is a radioactive isotope at any time T. So next question, we need to find the half-life of the isotope. The half-life, so means that kita kena cari
P dia.
T. Half-life. Buatlah.
Dah.
Dah, dapat tak?
Dah.
Kopi yang setengah.
Line.
Kena 100 tengah.
So P at T 300 exponent negative 0.01270. It is equivalent with 1/2 multiplied with 300. 150. Cari. Berapa? 150 divided by 300.
0.5.
0.5. Tak payah darab pun tak apa kan? 0.5. Okay, so take natural log left hand side, right hand side.
8, 6, 8, 5, 2, 9.
So T, I just keep natural log 0.0. Dia ada reserve life.
54.
50?
54.5785.
Dia Luhat
54.5785.
54.57.
54.54.
Oh, nampak.
5785. 85.
Okay, so T time dia.
Kena approximate tu tak payah.
Apa dia?
Kena approximate tu tak payah. Kalau time tak ada approximate. Maksudnya benda tak payah.
Kalau tak, dia kan macam final answer juga. Kalau tak 2 titik perpuluhan je boleh.
Boleh. So time kan.
Ya.
Dalam apa? Hours ke years? Years kan?
Years. Kena letak.
Therefore, T is 54 ataupun approximate lah, kita approximate 54 years ataupun 55 years boleh.
55 years.
Okay, sebab tu kita tak approximate value dekat situ. Hampir lebih kurang 55 tahun. Macam tu. Okay, so it is approximate to 55 years to reduce the radioactive to the half. Boleh?
Yeah.
Okay, very good. Last sekali, the amount of isotopes after 170 years. So this one you just substitute T
35.
into 170.
163.
Masukkan sahaja. Last
Dia dah makan.
170. So P at T 170 is equivalent with 300 exponent negative
0.0127 times 170. Dapat 34.322. 6322.
3
2.
Dapatlah 35.
milligram.
Oh, milligram.
Yes.
Okay, so these are the answers.
In 5 years.
Cik, nampak tak? Sebelah sini faham tak? Tak nampak?